Okay, so let's start. The reason why I've chosen 2019 past paper is because this paper is BAR 1412. BAR 1412. So you know the topics which are in this BAR 1412. Here we're looking at topics like nucleic acids, DNA replication, transcription and translation, then also gene regulation, cell cycle and the like. But I think for today we just concentrate much on that to be a DNA replication, then transcription, also translation, and maybe if at all we manage gene regulation. So focus on questions based on these. I'm sure these are the topics which you have covered so far, isn't it? Okay, so let's get into business. Can you see this paper? Kindly confirm. Okay. So this paper is saying School of Natural Sciences 2019 academic year. So it was written in 2019, which was BAR 1412. So previously how they used to do, to say that starting from 2020 going back, biology was divided into two. There was only BAR 1401, which was biomolecules and cells. Biomolecules and cells. Then there was also BAR 1412. BAR 1412, this was molecular biology and genetics. Okay? So at the moment, there's even a BAR 1400. For those of you who are who are taking health science related programs, you have BAR 1400. Then some of you have got BAR 1401, of which you have already written an exam. And now you're looking at BAR 1412. So the coverage here for BAR 1412 and semester 2 week for these guys, BAR 1400, is just the same. So here we are going to help, all of us we are going to be helped. Okay? So there's nothing like, no, this is BAR 1412, and what about us 1400? No, it's the same. Just that previously this is how it used to come. So this was BAR 1412. We are saying that here there are 100 multiple choice questions. But of course we are not going to cover all of them. Okay? But let's see how far we can go. And I just hope that you are aware on how you answer biology. You know to say that in biology there is a negative marking. So the moment you choose the wrong option, that is going to attract a negative one. Okay? Also leaving a blank space in an exam or a test is also going to attract a negative one. Then any option 6, that is I don't know option, will carry 0 marks. Okay? So this is something also that you have to take very serious. The I don't know option. You have to take it very serious. If you are not sure of the answer to the question, just put this option 6. You get a 0, rather than you putting a wrong option which you are not even sure of. You get it wrong, you have negative 1 deducted there. So make use of option 6. It's going to save you to have good or better grades. So let's get into business now. Question 1. So question 1 here reads, bacteria such as an E. coli grown on nitrogen 15 medium are transferred to nitrogen 14 medium and allowed to grow for one generation. Okay. DNA extracted from these bacteria is centrifuged. what density distribution of DNA would you expect in this experiment? So, so if you look at this question, from which topic is it coming from?
From DNA replication.
Yes, DNA replication. Where exactly? The same conservative of, yeah. So the same conservative of DNA replication, which is an experiment that was conducted by Messielson and the friend Starr. So we call this experiment as Messielson and Starr experiment. I'm sure some of you who have registered for these videos, you have watched the video here. There's already a video, we have already explained this experiment. So now we are saying that a bacteria was allowed to grow in a medium which contained heavy nitrogen, which is nitrogen 15. Then now it was, after some time, this bacteria was transferred into a medium which contained light nitrogen, that is nitrogen 14. So what density distribution would you expect this experiment to have after centrifugation? That is the question. So we have option 1, which is saying 1 high density nitrogen 15 and 1 low density nitrogen 14 DNA. That is option 1. Option 2 is saying 1 high density nitrogen 15 and 1 hybrid, that is nitrogen 15, nitrogen 14 DNA. So this type of DNA is what we call hybrid, where you have got two different strands. One is nitrogen 14, the other one is nitrogen 15. That is hybrid. Then 3, we are saying only hybrid, that is only nitrogen 14 and nitrogen 15 DNA. 4 is saying half nitrogen, half light nitrogen, that is nitrogen 14, and half hybrid, that is combined. Then option 5, only low density, that is you are only going to have nitrogen 14 DNA. Option 6, of course, I don't know. So what would be the correct option to this question? After one generation in a nitrogen 14. Yes, please.
Answer should be 3.
Answer should be
3.
okay. So our friend is saying the answer should be option 3. What about others?
Yes, I think the correct option should be 3 because it will be 100% hybrid.
Okay, so that is very true. So we are saying that this bacteria, at first, it was grown in a medium which contained the heavy nitrogen, that is nitrogen 15, nitrogen 15. So it was like this. Then now they changed the medium to a medium which now contained light nitrogen, which is nitrogen 14. Then they allowed this bacteria to grow for one generation in this medium. So what we know is that during DNA replication, if this is the DNA, these strands are going to separate. Each one of these is going to act as a template. So what we are going to have one strand here, nitrogen 15, and another strand here, nitrogen 15. Please, you can mute your mic. Those of you who your mics are on, please mute them. Okay? All right. So we are saying that in the first generation, nitrogen nitrogen 14, these two strands of this bacteria are going to separate. Each one of them is going to act as a template. So we have got a template here, another template there. But the new strand to each of these light nitrogen, heavy nitrogen, is going to contain nitrogen or that medium. So the nitrogen or the medium now is this nitrogen 14, meaning that the new strand here will be nitrogen 14. A new strand here will also be nitrogen 14. So what we have here, this is a nitrogen 15 and a nitrogen 14. We call this as a hybrid. So in the first generation, in light nitrogen, we are only going to have hybrid. Okay, so that should be the answer, which is option 3. So indeed, question 1, the correct answer is option 3. Any questions? Okay, so if you don't have questions, let's move on to question 2. Initiation of DNA replication takes place at the 1. Promoter sequence after the binding of the enzyme topoisomerase. Then 2 is saying origin of replication after the binding of DNA A protein. Option 3 is saying promoter sequence after the binding of DNA protein. 4, origin of replication after the binding of single-stranded binding proteins. Then 5 is saying origin of replication after the binding of the enzyme helicase. So what is the correct option to this question? Initiation of DNA replication.
It's option 2.
Option 2, origin of replication after the binding of DNA protein. What about others?
Yes,
Okay, so the correct answer to question 2 is option 2. Initiation will only start upon this enzyme known as DNA protein binding to the origin of replication. So what happens is that this protein known as DNA protein is always in motion, moving along the strands of DNA. So when it comes across a region which is rich in adenine and thymine bases, it will stop there. The region which is rich in adenine and thymine bases along the strand of DNA, this is what is regarded as the origin of replication. So this enzyme will stop at that point. Once it stops, then it's going to communicate with other sets of enzymes to come there to start the process of DNA replication. So that's how initiation of DNA replication starts. So the correct answer to question 2 is option 2. Question 3. The enzyme or enzymes and protein or proteins involved in the denaturation of DNA during replication are. So enzyme, we have enzyme and protein, okay, involved in the denaturation of DNA during replication are. Option 1, helicase and single-stranded binding proteins. 2 is saying topoisomerase, DNA polymerase, and their ligase. 3 is saying RNA polymerase, helicase, and single-stranded binding proteins. Then 4 is saying DNA polymerase, helicase, and the ligase. 5 is saying helicase, single-stranded binding proteins, and DNA polymerase. So what is the correct option to this question? The enzyme and proteins involved in denaturation of DNA during replication are. Quickly, let's listen. What's the correct answer to this question? What does it mean to denature first? Maybe this is the key term here. Let's respond. What is the answer to this question? Anyone to give it a try? Hello, is it that you are not getting me, or you just don't have you just don't know the correct answer? Are you getting me?
I think it's 1.
Okay. Let's give suggestions. I'm going to explain. What do others think is the correct answer to this question? Okay, so this question is in 2 ways. You have to identify an enzyme and a protein involved in a denaturation of DNA during replication. Hmm? I, 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 okay, even though I didn't get to. Okay, so we are saying that we,
Hello.
yes, go ahead.
My suggestion, the answer should be two.
Your suggestion, the answer should be two. Topoisomerase, DNA polymerase, and ligase. Okay, so two is disqualified for the fact that what is the function of DNA polymerase? The function of DNA polymerase is to add nucleotides to the newly growing strand. So that
Oh yeah, it's true, sir. Yeah.
mhm. Then ligase, the function of this ligase is to join what? The Okazaki fragments on the lagging strand. So it does not denature. Okay, and it's not a protein at the same time. So we're looking for an enzyme which is which is capable of denaturing DNA. So to denature, simply to break or to separate the hydrogen bond. So that enzyme is helicase. So for enzyme, we have helicase there. Then we are also looking at proteins. Okay, so if you have understood the enzymes involved in DNA replication, you'd agree with me that we only have got one set of proteins which are regarded exactly as proteins, and that is single-stranded binding proteins. So for enzyme, it has to be helicase, and for proteins, we are supposed to have single-stranded binding proteins. Hence, option 1 qualifies for this question as the correct option. Option 3 is disqualified for the fact that there is RNA polymerase. RNA polymerase, we don't have it in DNA replication. Option 4 is out for the fact that there is this DNA polymerase and ligase. Then option 5 is out because it has this enzyme, DNA polymerase. Okay? So the correct option here is option 1 for this question. Any questions? Any questions? So if there are no questions, we come to question, I think this is 5. Choose the statement which is correct. So we have 5 statements here. So choose one statement which is correct, okay? So option 1, the leading strand or the leading DNA strand grows in the opposite direction of the replication fork. Option 1. Option 2, the overall growth of all the Okazaki fragments is opposite to the direction of replication fork. 3 is saying individual Okazaki fragments grow in the opposite direction of the replication fork. Then 4 is saying the leading DNA strand is synthesized in the direction 3 to 5 prime end direction. Then 5 is saying each Okazaki fragment is synthesized in the 3 to 5 direction. So what is the correct statement here? And we can only have one true statement with respect to this question. So which statement is correct with regard to this question?
Option number 3.
Option number 3. So option number 3 is saying individual Okazaki fragments grow in the opposite direction to the replication fork. What are others saying? 2, the overall growth of all the Okazaki fragments is opposite to the direction of the replication fork. Okay? This is interesting. Some more suggestions or those who support these suggested options? Let's give suggestions. Girls, where are you? Girls. Okay, so in biology, the way it is that you can have about 4 correct answers, but you have to choose the best, the most best. That is going to be the correct answer. Okay, so here we are saying that option 3 is saying that individual Okazaki fragments grow in the opposite direction. That is true. Then option 2 is saying the overall growth of all the Okazaki fragments is opposite to the direction of the replication fork. Okay, so we come back here. You know to say that Okazaki fragments, if this is the, what direction is this? 5, 3 prime end. If this is one of the strands of DNA, we know that the direction of we're going to have another strand on top here, which is going to be 3 prime end to 5 prime end. So we know that we have got leading and lagging strand. The new synthesized strand, one is going to be leading strand, the other one is going to be lagging strand. So leading strand is the strand of DNA, which is synthesized in the same direction to the direction of replication fork. So let's say if this is the direction of replication fork, the new strand, which is going to be synthesized in this direction, same direction to the direction of replication fork, that is going to be known as the leading strand. So the new strand to the strand on top here is going to be like this. Okay? This will be 5 prime end, this will be 3 prime end. What do you know about this known as DNA polymerase 3? DNA polymerase 3, this is the enzyme which is responsible for adding nucleotides to the newly growing strand. So if we have a strand down here, for this strand to be synthesized, it needs this enzyme, DNA polymerase 3, to add nucleotides. Okay? So it adds one nucleotide at a time. And these new nucleotides, they are added at the 3 prime end. Now, another thing which you have to know about DNA polymerase 3 is that it can only add nucleotides in the direction 5 prime end to 3 prime end, and not this direction 3 to 5. Okay? It cannot add in this direction. DNA polymerase 3 cannot add nucleotides in this direction, but only in this direction. So if you come to this strand down here, where DNA polymerase 3 will still try to follow the direction 5 to 3. So the 5 to 3 down here, if this is our new strand, this will be the 3 prime end, this will be the 5 prime end. But if you look at the direction of replication, it's going in this direction. Okay? So, DNA polymerase 3, here it will be adding in this direction, opposite to the direction of replication. As a result, we are going to have what we call Okazaki fragments on this strand down here. Okazaki fragments. So what we can conclude from Okazaki fragments is that the overall growth of Okazaki fragments are synthesized in the opposite direction to the direction of replication fork. So that has to be the answer. Overall growth of these Okazaki fragments are synthesized in the opposite direction to the direction of replication fork. Because at no any point, these Okazaki fragments are going to be synthesized in this same direction as the direction of replication fork. That is why the overall growth has to qualify the correct answer to this question. So option 2 here has to be the correct answer to this question. Do you have questions? Any questions or some more clarity? Girls? Pardon? Okay. I thought maybe one of you was going to ask me that why some of these options are not correct. So let's move.
Sir, my question was, what's the direction of the leading strand? I'm kind of confused. What's the direction of the leading strand, and also what's the direction of the lagging strand?
Okay. That's a good question. So, I'll answer it from here.
I don't want to. I don't.
Okay, so let's do this. Direction of the leading strand. Pardon? Okay, you can mute your mic. Direction of the leading strand. You are okay. Please, can you mute your mics? I'm getting feedback. So direction of the leading strand, you have to know that these directions, it is with respect, leading and lagging strand, it is with respect to the new strands that we are synthesizing. So the leading strand is in the direction 5 to 3, like this. Okay? The lagging strand is in the direction 3. The direction is always 5 to 3. Just that this lagging strand is in reverse, where the leading strand is forward. That is the only difference. So what we have on top there, this is the leading strand. What we have down here, this is will be the lagging strand. Because it is in reverse. But the direction will always follow 5 to 3. I don't know if I've answered your question.
Yes, sir, you've answered, and thank you.
You're welcome. So we have this question now. If the sequence of one strand of DNA is 5' end, that those bases to 3' end, the sequence of the complementary strand would be, so you know to say that DNA is a double helical molecule. So if one strand of DNA has got this direction and those bases, what would be the complementary strand to this one here? So let's find our own answer here. What would be the direction? The new strand will start with what direction?
To be 3 to 5 prime.
Okay, so we start with 3' end. Then now let's have a complementary bases to these. Let's start with a thymine there. The complementary strand is going to have what base where the thymine?
It's A.
Then C,
G. That's G.
G,
C.
A,
T. C.
then T,
A.
A, C, G.
G.
Final direction? 5' end, right? So this is the answer. The new strand, the other strand, complementary strand to this will be like this. So 3' end to 5' end, these bases. Which option is that? Which option number is this? It's option number what?
5.
Yeah, so it's option number 5. So this is the answer. As you can see, 3' end, AGCT, AG, 5' end. It's exactly what we have here on option 5. So that's the answer there. Anyone who is behind? You are behind? No one. Hmm? Yes, please, go ahead. Option, okay. So that's also a good question. So option 3, you use it when you're considering you are transcribing from DNA to RNA. So this will be RNA. The reason why it will be RNA because you can see that there's uracil here. But here we are talking about the complementary strand within a DNA. So DNA, we have been given one strand. So we're looking at this other strand, okay? Complementary to this. That is why the correct answer will be this one. But if they say the RNA, the correct answer is going to be this one here, option 3. You're welcome. Another question? Okay, so we move to this question. DNA polymerase 3 adds nucleotides. I think this I've already explained. To the 5' end of the RNA primer, to the 3' end of RNA primer, in the place of primer RNA after it is removed. Option 4 is saying on a single-stranded template without need for an RNA primer. 5 is saying to both ends of RNA primer, that is at the 5' end and at 3' end. So where does DNA polymerase 3 add nucleotides? This one here is with respect to a primer. You know that the replication of this enzyme, DNA polymerase 3 cannot start adding nucleotides from without. It needs a primer. So you are going to have a primer, which is just a short sequence of RNA bases. So where does this enzyme known as DNA polymerase 3 add its nucleotides to this primer?
It's to the 3' end of RNA.
Yeah, so it is at the 3' end of RNA primer. So that is option 2. Anyone who is behind? Anyone who is behind? No one. Question 7. Time gas catalyzes the formation of covalent bond between dash of the nucleotide and the dash of adjacent nucleotide. So you can see here that we have got 2 blank spaces here, there and there. So your answer should also be with respect to these blanks. We are supposed to have 2 answers here. So enzyme ligase catalyzes the formation of covalent bond between dash of nucleotide and the dash of the adjacent side. What is the correct option there? One is 3 hydroxyl group and 5 hydroxyl group. 5 hydroxyl group, 3 phosphate group, 3 phosphate group, 5 phosphate group, 5 phosphate, 5 hydroxyl, 3 hydroxyl, 5 phosphate. What is the correct option? Ligase catalyzes the formation of covalent bond between dash of the nucleotide and the dash of the adjacent nucleotide.
Can it be option 2?
Option 2 catalyzes. So option 2 is wrong for the fact that you don't have hydroxyl group at the 5' end, at carbon 5. Option 5. So 3 hydroxyl group and 5.
5, yeah.
Yeah, so the correct answer is option 5. Okay? So you have hydroxyl group at position 3 of a nucleotide and a phosphate group at position 5 or the adjacent nucleotide. So option 5 for question 7. Any questions?